I know, you're probably like most people I know and hate dealing with fractions. Finding the least common denominator was a pain in and of itself. Now you have to deal with solving an expression with a fraction in the exponent. Well, in this video, I'm going to show you how to easily solve expressions with fractional exponents. After watching this video, you'll be able to solve any fractional exponent and ace your next exam. Let's get started. Okay, let's solve the problem negative 27 to the 1/3 power. The first thing I want you to understand is negative 27 to the 1/3 power is the same as saying the cube root of negative 27. This is just a notational difference in the writing of the problem. The problem is simply saying, what is the cube root of negative 27? So, to solve this problem, all we need to do is find the square root of negative 27, which is negative 3. Let's solve 0.25 to the 1/2 power. Remember, 0.25 to the 1/2 power is the same as the square root of 0.25. So, to solve this problem, all we really have to do is find the square root of 0.25, which is 0.5. Okay, let's solve some problems that are a bit more difficult. Let's solve the problem 8 to the 2/3 power. Since the exponent is 2/3, to solve this problem, we're going to do two things. First, we're going to find the cube root of 8, and second, we're going to raise the cube root of 8 to the second power. To make this process easier to see, I'm going to rewrite the problem as 8 to the 1/3 power raised to the second power. One side note, the denominator of the exponent tells me which root to use. Now that I have rewritten the problem, I'm going to find the cube root of 8. Since 8 is a perfect cube, I know 2 goes into 8 3 times. So 2 is the cube root of 8. Now that I have found the cube root of 8, which is 2, I want to raise 2 to the second power to get the answer 4. Let's look at another problem. Let's solve 64 to the 5/6 power. Remember, there are two things we need to do to solve this problem. First, we must find the 6th root of 64, and second, we must raise the 6th root of 64 to the 5th power. Again, to make this process easier to see, I'm going to rewrite the problem as 64 to the 1/6 power raised to the 5th power. Now that I have rewritten the problem, I'm going to find the 6th root of 64. I know 2 goes into 64 6 times, so 2 is the 6th root of 64. Now that I have the 6th root of 64, I can raise 2 to the 5th power to get the answer 32. Let's solve 1,000 to the negative 2/3 power. For this problem, we're going to follow the same process, but the very first thing we must do is rewrite the problem in the reciprocal. I want to do this to make the negative exponent positive. To write the expression in the reciprocal, you want to write the problem as 1 over 1,000 to the positive 2/3 power. Next, I'm going to write the denominator as 1,000 to the 1/3 power raised to the second power. Now you want to find the cube root of 1,000. Since 1,000 is a perfect cube, 10 is the cube root of 1,000. Since we have the cube root of 1,000, which is 10, you want to raise 10 to the second power. When you raise 10 to the second power, you get the answer 1 over 100. Let's do one more problem. Let's solve 32 to the negative 1/5 power. Just like in the previous problem, we're going to write the expression in the reciprocal. To write the expression in the reciprocal, you want to write the problem as 1 over 32 to the positive 1/5 power. Now that we have the problem written in the reciprocal, all we have to do to solve this problem is find the fifth root of 32, which is 2, giving us the answer of 1/2. If you found this video helpful, smash that like button and subscribe to the channel for more helpful videos just like this. Remember, algebra is simple when you start with the basics.